In this session, we're going to talk about two bivariate tests of difference. So with a bivariate test of difference, essentially we're looking at metric data, so interval or scale data, and we're looking at two different means, and we're trying to see if those means are statistically different from one another. But there are two different situations in which we'd like to do that, and understand the difference between these two is pretty important. The first is called an independent samples t-test. It means that we have samples from two different groups and we're looking at one variable. So for example, let's say we ask students the question how many Cokes they drank in a day on average. And let's say we get answers anywhere from 0 to 6. Well, we could ask that question of the undergraduate student population and then divide that population into men and women. And then we could use an independent samples t-test to see if the average number of Cokes or sodas consumed in a day differed for men and women. So in that case, we have one variable, which is the average number of sodas consumed in a day, and we have two groups, men and women. But there's another situation in which we'd be comparing the mean values for two metric variables, and that would be a paired sample t-test. So with the paired sample t-test, we have data from one group, but we're comparing the means for different variables. So for example, we could look at the entire undergraduate student body and just treat them as one group, one population, and ask them two questions. First, on average, how many sodas do you consume in a day? And second, on average, how many cups of coffee do you drink in a day? Then we could compare the means for those two variables. Again, one group, all undergraduates, two variables, how many sodas consumed in a day and how many coffees consumed in a day. Knowing which of these two situations you're dealing with is important, not only conceptually but also as you get into SPSS, because even though the interpretation is going to be very similar, we need to know actually how to conduct the test, what pull-down menus to use. So let's start first with an example that's an independent samples t-test. One of our variables is rent. We know how much rent on average our students are paying for a house or apartment per month. It'd be interesting to see if men and women are paying different amounts of rent. Now we don't know why that might be. We're not looking at causality here. It might be that men or women choose more or less expensive, or that maybe they are charged different rates. We're simply trying to understand if there's a difference in what men and women pay. And so this is two groups, men and women, one variable, rent. So what we're going to do is analyze, compare means. In this case, we have an independent samples t-test. My test variable is rent. My grouping variable is gender. And I need to tell it by defining groups how to look at my data. I know that I identified in Qualtrics men as -1, women as 1. Those were the codes that I want it to use. So I want it to compare rent for men and women. So there are two different tables here. The first one I want you to focus on is this, the group statistics. Before you look at any of the actual p-values and degrees of freedom, etc., you really want to get a sense of the data. We certainly could have graphed this data using a bar graph, but we can get a sense of it here as well. First of all, this is our sample. Our total sample happens to be 63. For this data set, we have 23 men and 40 women. Here's the mean rent. It looks as though women are paying on average $1,220 a month and men are paying $1,100, sort of rounded. So it looks like there's a difference of about $120. So the first thing we could say in a summary report is that the average rent that women paid was this figure, the average rent that men paid was this figure, and now we need to make a statement about whether or not that difference is significant. So now let's move on to this independent samples test table. The first thing we're going to see here is Levene's test for equality of variances. Let me tell you what this is, and then I'll tell you what we can do with it. Essentially what we're looking at here is the variance, or the standard deviation, the distribution of data around each of these means. Right? So each of these means is drawn from a population and we hope are normally distributed, but the variances may not be the same. So what this test is doing is testing to see whether those variances are the same. If the variances are not the same, then SPSS is going to use a more conservative test to evaluate the difference between these means. For now, however, let's just assume that we pass this test, and we can assume equal variances. In this case, we know that's the case because we have a non-significant p-value. This would be significant only if the variances were different. But let's just go ahead and ignore Levene's test and instead interpret this top row. So here we go, mean difference. This is the actual difference between the mean rent that men and women are paying. Is that statistically significant? It is not. Our p-value is certainly greater than our threshold of 0.10, so it is not significant. So when you write this up, you want to include, first of all, just the summary descriptive statistics, the means for men and women, and then you would say in this case that the difference is non-significant, and then you could report the t-value, the degrees of freedom, and the p-value, or instead of actually putting in 0.644, you could just say it's non-significant or it's greater than our threshold of 0.10. So that's an independent samples t-test. Now let's look at a paired samples t-test. So we've gone ahead in a prior session and created construct for decor and neighborhood. How much do you like the interior of your apartment or house, and how much do you like your neighborhood? So one research question could be, is there a difference in how participants on average rated how much they like their apartment decor versus their neighborhood? Again, you could inspect the data visually. I'm going to go ahead and show you the statistical test. We're still doing a comparison of means, but this time it is a paired samples t-test. So I need to tell it what pair of variables I'm interested in looking at. In this case, it's decor and neighborhood. Click OK. And again, the first thing that we want to do is look at the descriptive statistics, in this case the means. Now this is a scale from 1 to 7, with 4 being a neutral point. It looks as though, on average, participants in our survey do like their neighborhood, since this value appears to be greater than 4. And on average, they're kind of neutral when it comes to how much they like their apartment, or even slightly negative. The research question we have here, though, is the average mean here for neighborhood greater than the mean for decor? In other words, do people like their neighborhood on average more than they like their interior decor? So the first thing we'd want to do is just report the raw means. We could truncate this data here so that we have maybe just 1 or 2 decimals. And then we jump down to the paired samples test. Do not look at the correlations. Well, you can look at it, but we're not going to interpret this right now, because even though it includes it, because you could look at the correlation between decor and neighborhood, but that's not what we're trying to understand. We have a different research question right now, which is there a difference in the means? So we go to our paired samples test. Here's the mean difference between those ratings up ahead, the 5.2 and 3.7. And then for the significance, look over here for the sig. And yes, there is a highly statistically significant difference, p less than 0.001. So again, you would report these means, the mean difference, and then you could say it is significant with a t-value of negative 6.3, degrees of freedom of 63, and a p of less than 0.001.